and welcome back to Polar Equations. Today we are going to talk about converting our polar equations to rectangular form and vice versa. So a couple reminders about our polar conversion formulas. To go from our rectangular to polars, we could substitute x with our cos theta, y with our sine theta, and x squared plus y squared will equal our r squared value. Now, these also can kind of have some variations as well. Like, let's say, for instance, we squared all of these values, so we had x squared. Well, that's going to end up, if we distribute that square to everything, r squared times cosine squared. So that's something to keep in mind. Same thing with the y's. Like, if we squared all of these, y squared would be your r squared times your sine squared value. R also not squared, if we square root both sides, remember, can just equal x squared plus y squared. So these couple of variations are also some things we may be using that you may want to have jotted down as well. Now, as we go from our polars to our rectangulars, again, our goal each time is to have x and y in our final answer. And oftentimes that's going to look like different features we've seen before, circle equations, lines, all right, but your goal is ultimately to have x and y in your final answers where applicable. So for this first one, we are going to start by rearranging secant to be, not 1 over sine, 1 over cosine of theta. And what happens is if we multiply both sides by that cosine theta, we now have r times cosine theta on the left-hand side equals 7. Well, we know from our formulas up above that r times the cosine of theta can be substituted in with an x. So we could say x equals 7 is our final answer. For the next one, right now we have the cosine theta minus 2 sine theta in the denominator. For this next one, I would recommend multiplying that so that we kind of undo that denominator on the right-hand side and instead have it, if we multiply it, as part of the numerator on the left-hand side. So now we're at least not dealing with a fraction. We have r times cos theta minus 2 sine theta on the left, and then just equals 5 on the right. Well, if we distribute that r through, we now have r cosine theta minus 2 times r sine theta. And a reminder, we can again substitute r cosine theta with x. We can substitute in r sine theta with y. And that still all equals 5. And now we have our equation of a line with x's and y's. Now, ideally, it's nice to have this line rearranged so that it's in y equals format. So we could subtract the x from both sides. We would have negative 2y equals negative x plus 5. And if you divide everything by a negative 2 to simplify, we would have y equals, the negatives cancel, we have 1/2 x plus 5/2 or 2.5. By negative 2, so this is actually going to be negative 5/2. Now again, this format is super nice because we can see that this is a line. We can see our slope is positive 1/2, y-intercept at 0, negative 2.5 or negative 5/2. Our last example to go from our polars to our rectangulars, notice we have an r on the left and a cosine and sine on the right. Something that would be really nice, though, is if we multiplied both sides by an r, now we have these pieces up here that we can substitute in because we have r times r, which is r squared, and then we would have 5r cosine minus 9r sine. And that r squared on the left can be exchanged with an x squared plus y squared. And then on the right, 5x minus 9y. And if we bring everything to one side, subtract over the 5x and add over the 9y, what we notice is this looks like the equation of a circle. We can take each of our b values and divide them by 2. And then when we square that value, negative 2.5 squared is 6.25. And then that gets added to the other side as well. And then we can take our 9 divided by 2 and get 4.5. That value squared then gets added to both sides. So we have 20.25. So as we factor on the left, what multiplies to be 6.5 that adds to be negative 5, well, again, that number we got when we divided by 2 squared. And then same thing with the y's, y plus 4.5 quantity squared. And then last but not least, on the right-hand side, if we add our pieces together, 6.25 plus 20.25 would 26.5, and we see that equation of our circle. Now we also can take our rectangulars and convert them back to polars. So again, anywhere we see a y can now be r times the sine of theta. Anywhere we see an x can now be, in this case, r squared times cosine squared, because again, if we're squaring that x value, that would be our conversion up there. Now, what ends up being able to happen is the r here can cancel with one of the r's there through division, and our goal with polar to rectangular form is r by itself. So in this case, if I want to get r by itself, I can now divide over the 2 cosine squared so that r is alone. And on the left-hand side, we have sine divided by the 2 cosine squared. So our final answer, to make this a little bit prettier, r is going to equal, since again that's alone, sine of theta divided by 2 cosine squared theta. Now you may see your answer just represented like that. Sometimes what happens is we see this represented where cosine is broken up to be that cosine squared to be cosine times cosine. And then we would have 1 over 2, and the sine over cosine can be rewritten as a tangent, and then the 1 over cosine can be rewritten as a secant. So for instance, you might see your answer represented like that, where the 2's in the denominator by itself, or maybe they have just like 1/2 times each of those. Okay, so you might see it represented either way. All right, the next example, okay, we are going to convert again to multiple forms. Now, what I'm going to actually do first on this one is break this up so that this 3y squared is y squared plus 2y squareds. Because what this allows us to do is make a substitution in x squared plus y squared is r squared, and then 2 times our y squared value, which is r squared sine squared, and then minus 10 times our x value, which is just r cosine theta. And that's going to equal 0. Now again, ultimately our goal is to get r by itself. So what we're going to do is we're going to keep all of the r squared values, so the first part of this equation, on the left, and we're going to add that 10 times r cosine theta to the right. These now both have an r squared that we can divide out. We're left with 1 plus 2 sine squared. And then that's going to equal 10 times r cosine theta. Cancel these last couple out. This r squared can cancel with this r. And if we divide over this piece in black, okay, in parentheses, we have 10 cosine on the right divided by 1 plus 2 sine squared on the left. And this time, because of that addition in the denominator, it's as simple as that one is going to get. Our last example then on the next page has the x and the y. Okay, we can again substitute in for x and y. We have 2 times x, which is our cosine theta, plus 5 times our y value, which is r times sine of theta, equals 7. We have this GCF of r that we can take out. We're left with 2 cos plus 5 sine. And then last but not least, to get r completely alone, if we divide over, we would have 2 cos plus 5 sine as our equation. All right, thanks everyone for watching. We'll work more with these in class.